Welcome. In this video, we'll explore two fundamental concepts in C++ classes, static and const members. These features are essential for writing efficient, robust, and maintainable code. Whether you're new to C++ or looking to strengthen your understanding, this guide will walk you through the practical uses and syntax of static and const members, complete with real code examples and clear explanation. Let's begin by understanding what class members are and why static and const keywords are so important in object-oriented programming. Static keyword in C++ allows you to define class members that are shared across all objects of that class. Unlike regular data members, which are unique to each object, a static member exists as a single instance regardless of how many objects are created. This means all objects access the same static variable, making it ideal for tracking information common to all instances, such as counting objects or maintaining shared resources. Let's see how static members are declared and initialized in C++. Declare a static data member in a class, use the static keyword before the data type. For example, static InObjectCount creates a static integer variable. This variable is not tied to any specific object but belongs to the class itself. It's important to note that static data members must be defined outside the class using the scope resolution operator. This step ensures the static variable is properly allocated and initialized before use. Let's look at the syntax and see how it's done in practice. Consider a class called box. Inside this class we declare a static integer called objectCount. Every time a box object is created, the constructor increases object count by 1. This way object count keeps track of how many box objects exist. The static member is initialized outside the class using int box, object count equals 0. This approach ensures that all box objects share the same object count variable, and any changes are reflected across all instances. You run the box class example, you'll notice that creating two box objects results in the constructor being called twice. The static object count variable increases with each new object. When you print object count using either the class name or an object, the output is always the same, reflecting the total number of box instances. This demonstrates how static members maintain a single value shared by all objects, making them perfect for tracking class-wide information. Static member functions are another powerful feature in C++. By declaring a function as static, you make it independent of any specific object. These functions can be called using the class name and do not require an object to exist. Static member functions can only access static data members and other static functions. They cannot access non-static members or use the this pointer. This makes them ideal for operations that relate to the class as a whole, rather than individual objects. Declare a static member function. Simply add the static keyword before the function's return type. For example, static int getCount defines a static function that can be called without creating any objects. These functions are useful for accessing or modifying static data members, or for performing operations that don't depend on object-specific data. Let's see how static member functions are used in real code. The box class, a static function called getCount, returns the value of object count. This function can be called using the class name like box, getCount, or through an object such as box1getCount. Both calls return the same value since getCount operates on the static object count variable. This approach is especially useful for retrieving class-wide information without needing to create unnecessary objects. When you run the static function example, you'll see that calling getCount before creating any objects returns 0. After creating two box objects, getCount returns 2, whether you call it using the class name or an object. This demonstrates the independence of static functions from specific objects and their ability to provide class-level information at any time. Now let's shift our focus to the const keyword in C++. The const keyword is used to define values that cannot be changed during program execution. When you declare a variable as const, its value is fixed and any attempt to modify it will result in a compile time error. Const can be used in many contexts, such as with variables, pointers, function arguments, and class members. In this module, we'll focus on using const with class data members and member function. Const data members are variables declared inside a class with the const keyword. Once initialized, their value cannot be changed, not even in the constructor or destructor. This ensures that certain values remain constant throughout the lifetime of the object. Const data members are typically initialized using an initializer list in the constructor, since they cannot be assigned a value during declaration inside the class. Let's look at a practical example. In the ABC class, a constant a is declared. The constructor uses an initializer list to set the value of a once set, it cannot be changed. If you try to assign a new value to a later in the code, the compiler will throw an error. This approach is useful for defining values that should remain constant for each object, such as IDs or configuration parameters. When you run the ABC class example, the constructor prints the value of y, and then the value of the const data member a is displayed. If you attempt to assign a new value to a, the compiler will generate an error, reinforcing the immutability of const members. This behavior is crucial for maintaining data integrity in your classes. Const member functions are functions that do not modify any data members of the class. They are declared by adding the const keyword after the function's parameter list. These functions are also known as read-only functions, as they guarantee not to alter the state of the object. Const member functions can be safely called on const objects, ensuring that no accidental changes are made. Declare a const member function, simply add the const keyword after the function's parameter list. For example, void display const ensures that display cannot modify any class members. If you try to change a data member inside a const function, the compiler will throw an error. This provides a safeguard against unintended modifications and helps maintain object integrity. Consider a class ABC with a const member function fun. Inside fun, if you try to assign a value to a data member, the compiler will generate an error. This is because const member functions are not allowed to modify any class data. This restriction ensures that functions marked as const truly behave as read-only operations. Now let's see a successful use of const member functions. In the test class, the disp function is declared as const. It simply prints the sum of two variables a and b without modifying them. This is a perfect example of a read-only function where the function only reads data and does not alter the object's state. When you run the test class example, the disp function prints the sum of a and b. Since disp is a const function, you can be confident that it does not change any member variables. This makes const functions ideal for operations like displaying data, calculating values, or any task that should not alter the object's state. Summarize what we've learned so far. Static members are shared across all objects of a class, making them perfect for tracking class-wide information. Const members, on the other hand, are immutable and ensure that certain values remain constant throughout the object's lifetime. Both features help you write safer, more predictable code and are fundamental to mastering C++ classes. Static members are commonly used for counting objects, managing shared resources, or implementing singleton patterns. For example, you might use a static variable to keep track of how many database connections are open, or to store configuration settings that apply to all instances. Understanding when and how to use static members can greatly improve the efficiency and clarity of your code. Const members are ideal for defining values that should never change, such as mathematical constants, IDs, or configuration parameters. By marking these members as const, you prevent accidental modifications and make your code more robust. Const member functions are also essential for creating safe, read-only interfaces that guarantee no changes to object state. You can combine static and const to create class-wide constants. For example, static constant max size equals 100 defines a constant value shared by all objects. This is useful for defining limits or configuration values that should be the same for every instance. Combining these keywords leverages the strengths of both features for maximum safety and efficiency. Let's quickly recap the syntax for static members. Declare static data members with static before the type and define them outside the class using the scope resolution operator. Static functions are declared with static before the return type and can only access other static members. Remember, static members belong to the class, not to any specific object. For const data members, use the const keyword before the type and initialize them in the constructor's initializer list. Const member functions are declared by adding const after the parameter list. These functions cannot modify any data members or call non-const functions, ensuring they are truly read-only. One common mistake is forgetting to define static data members outside the class. If you only declare them inside the class, you'll get linker errors. Another pitfall is trying to access non-static members from a static function, which is not allowed. Always remember that static members and functions belong to the class, not to individual objects. With const members, a frequent error is trying to assign a value during declaration inside the class, which is not allowed. Another mistake is attempting to modify a const member in a function, which will result in a compile time error. Always use initializer lists for const data members and avoid modifying them after initialization. In real-world projects, static members are often used for logging, configuration, or managing shared resources. For example, a logger class might use a static instance to ensure only one logger exists throughout the application. Understanding how to use static members effectively can help you design more scalable and maintainable systems. Const members are widely used to define values that should never change, such as mathematical constants or configuration parameters. By marking these values as const, you prevent accidental changes and make your code more reliable. Const member functions are also essential for creating safe APIs that guarantee no side effects. It's important to understand the difference between static and non-static members. Static members are shared by all objects, while non-static members are unique to each object. Use static members for data or functions that should be common to all instances and non-static members for object-specific information. Const member functions guarantee not to modify the object, making them safe for use with const objects. Non-const functions, on the other hand, can modify data members and are not safe to call on const objects. Use const functions for read-only operations and non-const functions for operations that change the object's state. Remember, static data members must be initialized outside the class definition. This is done using the scope resolution operator like int className, member equals value. Failing to do this will result in linker errors. Always check that your static members are properly defined and initialized. Const data members cannot be assigned a value inside the class. Instead, use the constructor's initializer list to set their value. For example, className int x, const member x. This ensures the const member is properly initialized when the object is created. Static members can be accessed using either the class name or an object. However, it's more common and clearer to use the class name, as this emphasizes that the member belongs to the class, not to any specific object. For example, use className, static member to access static data or functions. Const data members are accessed just like regular data members, but you cannot modify them. Const member functions can be called on both const and non-const objects, making them versatile for read-only operations. This flexibility helps you write safer and more predictable code. Use static members when you need to share data or functionality across all objects of a class. Examples include counters, configuration settings, or utility functions that don't depend on object-specific data. Static members help reduce redundancy and centralize shared information. Use const members for values that should never change after initialization, such as IDs, constants, or read-only configuration. Const member functions are perfect for operations that only need to read data, ensuring that your objects remain unchanged and your code stays reliable. Static member functions cannot access non-static data members or use the this pointer. They are limited to working with static data and other static functions. This restriction ensures that static functions only operate on class-wide information, not on individual object data. Const member functions cannot modify any data members or call non-const functions. If you attempt to do so, the compiler will generate an error. This limitation ensures that const functions are truly read-only and safe to use with const objects. Combining static and const is a common pattern for defining class-wide constants. For example, static const double pi equals 3.14159 creates a constant value accessible by all objects. This approach is perfect for defining values like mathematical constants or configuration limits that should never change. When using inheritance, static members are shared across the entire class hierarchy, while const members remain constant for each object. This means that derived classes can access static members of the base class, and const members ensure data integrity in both base and derived objects. Always initialize static data members outside the class, use static functions for class-wide operations, and avoid accessing non-static data from static functions. Use static members judiciously to avoid unnecessary coupling and ensure your code remains modular and maintainable. Use const members for values that must not change and always initialize them in the constructor. Mark functions as const if they do not modify the object. This practice improves code safety, readability, and helps prevent bugs caused by unintended modifications. In technical interviews, you may be asked about the differences between static and const or to write code using these keywords. Remember to explain that static members are shared by all objects while const members are immutable. Be ready to demonstrate proper syntax and discuss real-world use cases. To wrap up, static and const are powerful tools in C++ for managing class data and behavior. Static members are shared across all objects, while const members ensure immutability. Mastering these concepts will help you write safer, more efficient, and maintainable code in your C++ projects. In the next module, we'll explore inheritance, another cornerstone of object-oriented programming. Inheritance allows you to create new classes that reuse, extend, or modify the behavior of existing classes. Stay tuned to learn how inheritance works in C++ and how it interacts with static and const members.